Hello everyone. I'd like to talk about the Euler's method, which is a numerical technique that used for approximate the solution of an ordinary differential equation. So how does it work? So imagine we have the initial point. Let's call is x0, y0, according to the photo on the left hand side. So we have the initial value a0, y0. Then at this point, we know the slope of our function. The slope is given to us by our differential equation, which we can call f of x and y n, or maybe dy by dx. What we do is we use this slope, our current x and y values, and a small step to figure out our next approximate value. We move forward a tiny bit along the x-axis. That's our step size, which we call h. By taking that small step, we can estimate what our new y value will be, and we keep doing this until we reach our desired x value. And now let's look at how we get the formula for our new y. So we know the slope is fundamentally change in y over change in x. So if we think about it, change in y would be y1 minus y0. Then change in x will be the step size, h. Then the slope is initially we call f of x0, y0. So we just substitute it, and then we will arrange it to get the formula of y new. So let's put this into practice with an example. The initial x value is 0 and initial y is 1 according to the question given. So for our first round, let's estimate our step size at h to be 0.1. What I do first is list out my x value until I reach x equal 1. So I have x value to add like this, a1 plus 0.1. Then I add all this x value 0.1 until I reach 1. Then for each step, then I find the slope value. For each step, I use differential equation given according to the question. So when how to derive? I just use the either column a2 square plus 1 and divide by b2. Then I just calculate it until I substitute x equal 1. Then how to get next y value? I use the formula. Just now I derive it. Then I just substitute the values that I need to do, like y0 plus h times the slope. Now, after going through all these steps, using the formulas, then I get the final values of y. Now, since Euler's method gives us an approximate value, it's always good to compare to the exact solution. For the specific differential equation, I can find the general solution in terms of x. So I use the dy by dx equal x squared plus 1. Then I find the formula of y in terms of x. I substitute x is 1, since the question want y of 1. Then I get the y value. Once I have both the approximate value and the exact value, I can calculate the absolute error. I will repeat the whole process by using the step size 0.05. Then I calculate the steps just like above. Now, after running through our process, now let's look at the absolute error. So when I calculate it, I find that the absolute error is even smaller than before. That I found out that if we use a smaller step size, the absolute error also becomes smaller. That means our approximate solution is much closer to the true real solution of the differential equation. So that's how Euler's method works. Thank you.